Lesson 3.7. Solve quadratic inequalities. Alright, so inequalities now. They're similar to the equations, but there are some differences. First of all, I'll say make it equal to 0. So really what I want is 0 on one side. It won't have an equal sign, but I'll have a 0 on one side. And then you're going to factor or use the quadratic formula to find the zeros. So now you're pretending it is equal to 0 and solve it. Alright, so let's go ahead and do that. So we'll subtract the 5. Alright, let's try getting our zeros by factoring. So we have p, and to get negative 5, it would be negative 5 and 1. Check it, it works. Each one of those equals to 0. So I get 5 and negative 1. It says graph those on a number line. All right, here's a number line. 5. Here's a 5. I'm using a filled in dot because our original inequality had equal to. And then negative 1 would be right there. Again, I'm using a filled in dot because it was less than or equal to. Notice it cuts our number line into 3 parts. We have less than negative 1, between negative 1 and 5, and greater than 5. We're going to pick a number in each of the 3 parts as a test point. So maybe we could test negative 2, 0 is really handy, and 6. Test those points to see if they're true or false. All right, let's start with the negative 2. So just plug them into the original one. So negative 2 squared minus 4 times negative 2. Is that less than or equal to 5? I don't know. 2 squared is 4. Negative 4 times negative 2 is 8. So I get 12 is less than or equal to 5. No, that's false. Let's try the 0. 0 squared minus 4 times 0, less than or equal to 5. That'd be 0 is less than or equal to 5. That is true. All right, for this true section, I'm actually going to put the line over it. My graph. And then try the 6. 6 squared minus 4 times 6, less than or equal to 5. So that would be 36 minus 24. So that'd be 12 is less than or equal to 5. No, that's false. We're going to write inequalities for the regions that were true. So in this case, it's between the negative 1 and 5, and we used p in this case instead of x. And I have less than or equals because our original problem was less than or equals. All right, let's solve this inequality. Start by getting everything on the one side, so I'll subtract the 45. All right, pretend it's equal to 0 and solve. So let's attempt to factor. To get x squared is x times x, and 45, I don't know, negative 9 and 5. Check it. 5x minus 9x is in fact negative 4. Each of those equals to 0. So x is 9 and x is negative 5. Put that on a number line. All right, this time it's open circles because it's just greater than. It doesn't have the equal part. Again, open circle. Then we need to pick test points. So let's test negative 6. 0 is always handy. And 10. So we'll try the negative 6. So that's 36 plus 24. So that would be 60 is greater than 45. That is definitely true. So we want things down there. Let's test the 0. Because 0 is greater than 45. That's not true. That's false. And then we have the 10. It's 100 minus 40. So that's 60 is greater than 45. That is also true. So it's the part up there also. So our answer is x is less than negative 5, or x is greater than 9. It might be nice, though, to not have to do the test points. Is there a shortcut? Yes, there is. So we could think about graphing the quadratic. Thinking shortcut? Yeah, it is. Make the inequality 0, and you graph. Now, it does have to be a great graph. What I'm going to show you in this first example does have a wonderful graph, but it could be a really, really rough graph. Okay, I have all these beautiful points. Really, all you have to know is whether it opens up or opens down. Remember, if A is positive, it opens up. If A is negative, it opens down. When the graph is below the x-axis, it's less than 0. So this one is less than 0 between negative 3 and 1. The graph is above the x-axis. That's up here. It's greater than 0. So you can just look and see what you need. Try it in our first example. All right, so this one is already set up to 0. We still need to factor, use the quadratic formula to get the zeros. The x squared is x and x. The negative 20, I don't know, is 5 and a minus 4. Add those together, I get the 1x. Each of those equals to 0. So x is negative 5 or 4. Put those on a number line. All right, now it's just greater than, so I'm going to use open circles at negative 5 and 4. And now I'm going to put a graph. Really, all I need to know is, does it open up or down? Since that is positive for the leading coefficient, the a, it opens up. So I know it's going to look something like that. Like I said, it doesn't have to be a great graph. All I have to know is open up or down. Now, I also notice it's greater than 0. So where's my graph above? It's above on the ends. It's above the x-axis on the ends. So it would be x is less than negative 5, or x is greater than 4. And there, we have solved it. If it had been less than 0, we would have used the middle. Let's try one more. All right, let's try factoring. If you don't want to factor this one, you could use the quadratic formula. To get the negative 2x squared, it might be negative 2x and x. To get the negative 4, we might use negative 1 and positive 4. And then we can check. Maybe that would be negative 8x minus 1x is negative 9x. That worked. All right, so erase my check step. All right, set each of the factors equal to 0. Add the 1, divide by -2, so it's -1/2, or -4. Put that on the number line. It is equal to, greater than or equal to, so I'll put solid dot at -1/2 and -4. Now, the a, is it positive or negative? In this case, it is negative. It is a -2. So that means it opens down. So it's going to look like that. And it's greater than 0, so I want it to be where the graph is above the line. It's above, right there in the middle. So my answer is -4, less than or equal to x, less than or equal to -1/2. So